Hello friends, welcome to this video. So in the last video we talked about nuclear fission reaction. So let me quickly discuss what is nuclear fission. In nuclear fission, a heavy nucleus like uranium-235 is bombarded with a neutron particle and we get these products like this, okay? So we get some other smaller nuclei and again neutrons, okay? So why this nuclear fission reaction is important? Nuclear fission reaction is important because such reactions can generate a lot of energy, and this energy is used in the generation of nuclear power. Okay, so that is what we learned in the last video. So now the question is, why does so much energy is generated in a nuclear fission reaction like this? So about that we are going to learn here. Okay. So in one of our earlier videos, we learned about the binding energy per nucleon curve. Okay, so about that, I'll give the link to that video somewhere in this video. So what happens? We saw that if we have some heavy nucleus with about say, let us say 240 number of nucleons, and that is broken to two other nuclei with each having number of nucleons about 120. So we found that these nuclei are more strongly bound, or simply these nuclei have got higher binding energy per nucleon as compared to the parent nucleus. Okay, so from that graph you will see that this parent nucleus would have some binding energy per nucleon value of about 7.6 mega electron volt, and such a daughter nuclei or the nuclei which we would get after breaking the parent nuclei, and they will have binding energy per nucleon value of about 8.5 mega electron volt. You see, therefore these daughter nuclei are more strongly bound as compared to the parent nuclei, and that is why we can get to see that this binding energy per nucleon is greater than the in binding energy per nucleon of the parent nucleus. So now you see there is obviously a difference of 8.5 minus 7.6 mega electron volt. So it gives us 0.9 mega electron volt. Okay, so 0.99 mega electron volt, there is a difference in binding energy, or we can say that the gain in binding energy, rather we can say that the gain in binding energy is 0.9 mega electron volt. Okay, the gain means the gain after the breaking. Okay, so what we are trying to discuss, we are trying to discuss how much energy is generated during a nuclear fission reaction like this. Okay. So here also uranium 235 from that graph you see will have lower binding energy per nucleon than compared to these two. Sorry, than compared to these two daughter nuclei. Okay. So the gain in binding energy is 0.9 mega electron volt. Okay. So then what is the total gain in binding energy? Okay, what is the total gain in binding energy? How we can calculate that? So we can calculate that by multiplying 240. Okay, 240 was the number of nucleons of the parent nucleus. So 240 multiplied by 0.9 mega electron volt. So which would give us about uh, let me calculate, 216 mega electron volt. Okay, so 216 mega electron volt is the total gain in binding energy. Okay, when a parent nucleus of 240 nucleons is broken into two daughter nuclei, each having uh, the number of nucleons equal to 120. Okay, so you can imagine this much energy is released. So very high amount of energy is released. Okay, this amount of energy 216 Mega electron volt is actually very high amount of energy, and this is what we were discussing in the last video when we discussed about nuclear fission, that that is one of the advantages of nuclear reactions. Nuclear reactions like nuclear fission, that same amount of material, same amount of uranium, okay, same amount of uranium can give this very high amount of energy as compared to coal. Okay, so this very high amount of energy is obtained from nuclear fission reactions. Now the question is, what happens to this energy after a nuclear reaction has happened? Okay, after nuclear fission reaction has happened, so what happened to this energy? This much energy is actually the kinetic energy of the fragments. Okay, fragments and the neutrons. Okay, fragments and neutrons. This is the kinetic energy of the fragments and neutrons. Okay. So fragment means this barium, krypton, and the neutrons. So now the question is, and what happens to this energy? This much energy is released into the environment. Okay, released into the surrounding as heat. Okay, since it's kinetic energy, so large amount of heat is produced during the course of such nuclear fission reaction. Okay, needless to talk about what happened in Hiroshima and Nagasaki, maybe many of you know. So those were uncontrolled nuclear reactions. Okay, but in order to generate power or to produce electricity, what we have to do, we have to harvest the energy, harvest this much energy, or we have to perform nuclear fission reactions in a controlled way, in a more controlled way. Okay, so we need to perform nuclear fission reactions in a more controlled way so that we can utilize this enormous amount of heat. Okay, and that is done by nuclear reactors. Okay, nuclear in nuclear reactors, such nuclear fission reactions are, okay, done in a controlled way. Okay, in nuclear reactors, such nuclear fission reactions are done in a controlled way to generate electricity. Okay, so yes, so I think that is, you have understood how this enormous or huge amount of energy is produced in a nuclear fission reaction like this, and this much energy has to be harvested, and a controlled nuclear reaction in a nuclear reactor has to be done to get nuclear power. Okay, so nuclear reactors is a different topic and itself, and we will learn about that topic in one of our future videos. So thank you friends, I hope you have understood the contents of this video, and thank you very much for watching, and I will see you in the next video. Thank you very much.